Welcome, everyone. My name's Mark Hughes, and I'm part of the team at Advanced Assembly in Aurora, Colorado. I'd like to thank everyone for taking time out of your busy day to join us for this webinar. For your convenience, we will record this webinar and send it out to you in a few days. We keep listening to our customer requests at our last webinar, and for this one, we've chosen to answer your questions about DFM and DFA. Please ask them in the Q&A box, and we will either answer them as we go along or at the end of the webinar. Now for our presenters, Elijah Gracia of Royal Circuit Solutions and Chao Vang of Advanced Assembly. Elijah is a lead engineer at Royal Circuit Solutions in Hollister, California. He's been working for Royal for 6 years, perfecting the science of PCB fabrication. Chao Vang is an engineer manager at Advanced Assembly in Aurora, Colorado. Chao has been assembling boards for 11 years. Both presenters encounter problems that stop boards from being built dozens of times every day. So we're here to learn from their experiences. The presentation's divided into 2 parts, PCB fabrication and PCB assembly. So to find out how to streamline the build process in your next design, here are Chao and Elijah.
Hey,
Welcome,
everyone.
guys. Elijah, would you like to introduce yourself?
Yeah, definitely. How's it going, everybody? I'm Elijah Gracia from Royal Circuit Solutions, and we're a PCB fab shop here in Hollister, California, specializing in quick turn and prototype circuit boards, including rigid flex, and flex.
Well, hey, man, thanks for joining us today. Chao, are you there?
I'm here. Hi, everyone. I work for Advanced Assembly, and we are a Colorado-based company specializing in quick-turn SMT assembly. And in the last decade or so, we've assembled more than 45,000 unique designs, and we're just continuing to grow thanks to customers like you all.
Great. So I know a lot of people are working from home and whatnot today. Are your company shut down and you're just hanging out, or what brought you to us today?
In regards to Advanced Assembly, we're fully running. I just happen to be working from home, but everybody else is working at the company. So we're all full functioning, no distraction, no anything of that nature.
Oh, cool. How about you, Elijah? Is Royal still pumping out boards?
Yep, we're still running. We kind of have a skeleton crew, but we're going strong.
So you guys must be essential businesses. What are you doing that's so essential that you guys can't be home with your families?
We're actually making circuit boards for one of the companies that are making the ventilators for this whole COVID-19 crisis. So a couple other things, but that's one of the big ones.
No kidding. Well, hey, man, keep up the good work. I know I appreciate it. I'm sure others do too. All right, let's get going. And again, if you guys have any questions, feel free to ask them as we go along in the question and answer at the bottom. So today, I was hoping we could go over holds and delays, talk about some design guidelines and fabrication issues. Then we'll move on to assembly issues, talk about some do's and don'ts, and at the end, we'll take any questions that we don't get along the way. Sound good? Yep. Elijah, am I talking to myself?
I think
You're
so.
making me sad. Okay.
I'm sorry. I thought that was a general question for the viewer.
Oh, no, it was not rhetorical. I know. Anyways. All right. So let's start off then with our holds and delays. Sound good?
Yep.
All right. So what is a hold and delay?
Yeah. So let's talk about our hold and delays and kind of the process we use for our holds. Really quick, the reason here at Royal that we want to avoid holds is because when we have to ask you a question, depending on the time of day and your availability, this can take from 5 minutes or even a couple hours or a couple days to get that answer sometimes. So we really want to avoid that. So really quick, how are errors being discovered and why do we hold your orders? So usually at the time of quote, we're able to plug in your files into our DFM and DFA software. And that's kind of like a spell check. That's the best way to describe it for your design and your assembly process. And the software we use is able to find all of the big and small issues based on the rules that we apply. And so at the end of the check, we're able to give you a report on anything that we're going to have issues with during the build. And so like an example to the left is if the spokes on your thermal pads are too thin for the software, it's going to catch that and we're going to be able to fix it right away. And if you fix these errors now on your side, we're going to avoid the worst case scenario, which would be us having to restart the job from scratch when you send the new Gerbers. Chow, do you want to explain the DFA holds?
Yeah, so DFA holds are once we actually take all your files and review them, every engineer is actually IPC trained. And so if they see parts conflicting or there's spacing violations or parts that don't fit or orientation issues, those are the type of DFA holds that we would catch while we're reviewing your job. And if they don't fall within IPC standards, we'll flag you for it and get some sort of resolution in order to proceed.
So how often do you guys have to hold jobs?
On the Royal side, every day for sure. It's usually a couple of the problems that we're actually going to go over next, but these are things that can be solved. Again, I think this webinar will be able to help you really get past a lot of those.
So how many customers do you have like a rough percentage of how many customers projects you put on hold because of problems?
I would probably say 20%.
20, okay.
Yeah, and I think that's because the majority of the customers are returning customers, and the longer you're with us, the more you get to know our rules and you can avoid all these things.
All right, and Chow, about how many of your boards do you think go on hold?
So for us, we actually have 25 to 35 unique designs booked every day. And so of those numbers, I would say about 75% of those actually go on hold for some sort of reason that we just talked about. And so on our side, we see a lot more issues. It may be one issue, it may be up to like 20 issues. And so, but a majority of the jobs that we see go on hold.
Crazy. All right. Well, let's jump into it then, shall we?
Yeah.
All right. So design guidelines.
All right. So let's go over a few simple design guidelines to help you out. The first thing we want to mention is the fabrication guidelines. And any board shop that you use is going to have their own specific guidelines for you to follow. And that's based on that shop's capabilities. So be sure to check that list before setting up your job and your design so that you can get success from the very start of your project. And if you're using Royal circuits, we have a huge list of design rules to use depending on what kind of specs you're trying to achieve. And I can't stress enough how valuable these documents are. They're going to save you and the board shop a lot of time and money. So check them out when you get a chance. And if you have any questions, be sure to shoot me an email and we'll get everything cleared up for you.
All right. So we've got a couple questions, and let me remind participants, if you can, please use the question and answer, and rather than the chat. The question and answer can be viewed by all participants. The chats just come to me. So I see up here that we have Eagle, and this might be old information, but do we have those files in other formats such as Altium and OrCAD?
I haven't seen them. I can find that out and get that back to you.
Okay. I mean, Altium's a pretty popular tool. Maybe if that's something that we don't have, maybe that's something that we can get up on the website.
Absolutely, yeah. Now's the time to definitely do that.
Okay, so I don't know how to quite pronounce the name, but I'm gonna give it a shot. Jelani, if it's not there for you, we'll get it there for you. We recently redesigned the website, so it's quite possible that some things got overlooked, but we'll get that taken care of for you, okay? So thank you for that question. Jackson says Altium design rules would be very useful for us. I agree entirely. So like I said, if we don't have that on the website, we will get that on the website. And not to be left out, Jelani also wants OrCAD's pads format. All right, buddy, you're gonna put us to work, but we'll find a way to make that happen for you, okay?
Definitely.
So we've got a question. It says, is there any advantage to providing a set of Gerber files rather than an ODB++ export for fab and assembly? I will start on that one for you, Raylan. Somewhere upward of 95 to 98% of the files that we receive on the fabrication side are Gerbers. ODB++ includes additional information, but it also still has the same data that the Gerber has. it doesn't do much for us. We also take, remind me, Elijah, is it IPC 2581?
Yes.
Okay. We also take IPC 2581, which has even more information. So are there advantages? Yes, but people don't seem to be taking advantage of any format other than Gerber. Most of our files are just Gerbers. Now you go over to assembly, that might be a little bit of a different story, but from your question was, I think, fab. So we'll go there. Chow, do you have any questions regarding file formats for assembly?
So on the assembly side, our particular software right now, we only import Gerbers. But if customers supply ODB++, we have another software where we would actually use that to extract the Gerbers from the ODB++. So essentially, we will only be using Gerbers. For right now, we are in the process of developing or upgrading our current software to import raw CAD data, which in the future we will be able to use ODB++ as it is without exporting or using Gerber's files.
Okay, cool. All right, we're getting a ton of questions. We've got a lot of participants today. Another request for pads. Okay, we got you. Question from TMSI Tech. Is it possible to somehow request the DFM, DFA requirements for Altium? Yes, if we don't have them on the website in the format you want, I'll put in a request with our guy Raj to get those exported in all common formats. Eagle, KiCad, Pads, Altium, Designer. We'll put in the request for you. And KiCad 2. Okay, and KiCad 2. You got it, guys. I'm not forgetting about you. I'm dismissing some of these repeat questions. Okay, so David Pasella, what are the pros cons of working directly from the CAD, i.e. Altium.PCB versus traditional Gerbers? There are definite advantages when you start doing other things with those files, but as far as fabrication and assembly goes, we still use the same old that's been going on for the last decade to fabricate your boards. You can, if you start using other tools such as Inspect AR, which is our board augmented reality bring up tool, definitely we want the CAD files. But for fabrication and assembly, nothing's really changed all that much recently. Okay, rules for HF PCBs. The best way that you can do that, Gregor, is talk to our layout engineers, Omar, and is it Teresa? Elijah, who's our?
Yes.
Okay, Teresa. And they will work with you, create a custom stack up impedance controlled, and they will give you rules and a board stack up specific to your design requirements. We won't post that on our website, but it's free. You don't have to pay anything. You just call your salesperson, say, hi, I need this, and they'll schedule a time for you to talk to Omar and Teresa, probably the same day, and get you started on your file. Does that sound good? All right. Elijah, I'm sorry, no, not Elijah. Chow, does Advanced Assembly have any .dru files?
We actually don't have any available. What I would suggest is as long as you follow the manufacturer's recommendations for footprint, that's actually what we're looking for as well. Because if you follow those design rules by the data sheet by the manufacturer, your part most likely almost 100% of the time will fit and per IPC standards. If it doesn't, and that's when we'll catch it for you. But right now we don't have any.
Okay. Jelani says, do we have any ICT fixtures for boards? If so, won't you require an ODB++ file or IPC 2581? We don't make fixtures at this time. However, we do have a partner company that does. They would need those, but we don't do the fixtures in-house at this time. So we don't specifically need them. What software we're using to perform DFM, DFA analysis? We've got a bespoke software solution. Is it No, it's not ARCAD. Archeo, is that the name of it, Elijah?
Are you talking about the UCAM?
For our DFM, DFA analysis.
Oh, yes, that's going to be Archeo.
Archeo. Okay, so we've got a bespoke software you've probably never seen. We had it made just for our company. It's proprietary, I'm sorry. Do we have any specific rules for types of solder alloys to use depending on components and application? I need to put you in touch with, and then we need to move on, but we would need to put you in touch with one of our design engineers specifically, Tim. We would not post that on the website. We would just use our typical paste jet printer, whatever is loaded in that. If you needed something different, then we would have to come up with a specific profile for you. Question is, what IPC class, and this is the last one on this topic before we move on, what IPC classes are available for bare boards and assembled boards? We require a mix of 2 and 3. We can give you a mix of 2 and 3, Jesse. So like if you want class 3, whatever, and then you want class 2 something else, like let's say vias, it's okay if they drift outside a little bit for you. We can do that for you, absolutely. And that'll save you some money too, if the whole design doesn't have to be class 3. We can absolutely do that for you over at Royal. Contact your salesperson, or just, how do we do it? Is it just sales at Royal Circuits, Elijah?
Yeah, sales at Royal Circuits if you don't have a specific sales assistant.
Okay, well, all right. Let's move on. And again, if you have questions, please use the Q&A. All right, so moving on to trace and space. What can you tell me about that, Elijah?
Yeah, so obviously with different copper weights, you're going to have different trace and space minimums. And this chart here, useful tool that we provide, it's going to show our minimum trace and space. And on the left side, we can look for the copper weights that you're going to be using and then follow the minimum trace and space rules. And there's slightly different rules when you're dealing with inners and outer layers. We are able to get tighter gaps on the outer layers and the inner layers just because of the nature of the process. But we can usually meet your design just by changing the copper weight. And but if you follow the simple chart right here in front of you from the very beginning, then you won't be running into any surprises. And just to clarify, these are the minimum values. You should be using larger tray sizes and spacing whenever possible to increase your overall yield. But lower risk means lower cost per board. So you definitely want to try to exceed these.
All right, is this really the smallest you can go?
No, we can break these rules. That does come with some price adders and a little more DFM work. We really have to inspect the board, and sometimes the process engineer might have to babysit your board through the entire process, but we can break these rules.
Cool, thanks, Elijah. We've got a question from Jackson. What about 1.5 ounce? Yeah, we can get that copper for you. We just didn't put it on the chart to reduce clutter. We've got 1.5 sitting on the shelves. It's just a make a pretty graph thing. So we can do that for you. Or if you want, we can do, half ounce and then do an ounce of plating. It's up to you. Here's a question I don't know, Elijah. Do you offer circuits with thinner copper? Do you go smaller than 1/4 ounce?
1/4 ounce is our smallest.
What about over at Flex? Do they go smaller?
Yes, I believe Flex does go smaller than that. There are special processes where we can reduce the copper weight, but again, that's just that definitely comes with price adders because it's the process engineers really have to watch over these and make sure through every process that those traces are holding their integrity.
Yeah. So Stephen, we have 2 factories, one up in Central Northern California and one in Southern California. The Southern California does our rigid flex and our flex circuits. They can go smaller, no problem. But right now we're talking with the Northern factory. We're talking with rigid only at the moment. So yes, but not with the guy we're talking to. So thanks, Stephen. Fred asks, I assume these are finished weights for outer layers on the chart. Yeah, they are. The reason that you can do different trace and space on inner and outer is because of the plating issue. And you don't have to have so much etch back compensation because you can plate, roughly straight up. So thanks. Is this starting copper weight or after plating? We just did that one. This is after plating. Do the 1.5 ounce spacings follow the 1 ounce and 2 ounce rules? So Jackson, these are, let's call them preferred minimums, right? So if you wanted the 1.5 ounce, you know, let's call the trace 4.5, the space 6, the outer space 6, and the inner space 3.5, somewhere in there. But if you want it to be thicker, if you want it to be thinner, they can do that. They can make your traces smaller at the risk of having a decreased yield. So you're going to get fewer boards per panel, which means at the end of the day, you end up paying a little more, right? All that changes is your yield when you start pushing these numbers down. But they can do it. You'll still get some good boards out, but you'll also have to throw some in the trash. So, Elijah, how well do you control plating across the panel to assure RF trace conformance? How good's our plating?
Our plating is amazing. We actually have these really cool custom-made pulse plating tanks that are able to control when the customer is asking for a very specific, very uniform amount of plating across the panel. These tanks we had custom made, had some awesome engineers come in and kind of work with our lab in getting the chemical formulas right. And yeah, it's amazing what they can do.
We've got a chemist on staff, Glenn, that checks our plating tanks constantly, make sure that everything's dialed in. I mean, that's really all they do. And then we also have quality control on site that checks and rechecks and adjusts things as we go. So thanks.
Yeah, I think our lab tech checks it every 3 hours.
Something like that.
Yeah, it's pretty awesome.
It's just like all they're doing. It's crazy. All right. So what are some common fabrication issues you see?
Yeah. So let's go over some of the common fabrication issues that we see here at Royal Circuits. And these are all very minor issues, but they can be cleaned up and clarified before you even send your Gerbers. And that's going to keep your order running smoothly into production. So the first issue that I see here every week is customers not specifying their plated and non-plated holes in the design. In the example right here, we have 4 black holes that are pretty obvious, which look like they should be non-plated. Everything else looks like it should be plated, right? And if a customer doesn't provide a drill chart that tells me that which holes should be plated and which holes should be non-plated, then I'm going to place it on hold so that I can clarify what we're building is correct. And at other times, sometimes a customer does provide a drill chart, but maybe they didn't double check it, and I might see something sketchy like those 4 black holes clearly calling for plating. Then I'm going to place that on hold and just verify that there is an issue in the drill chart. So provide your drill chart and double check it.
So we're looking just to clarify right here, guys.
Yeah.
So.
No plating.
Okay. All right. Thanks, man. By the way, just because we're starting to go a little long, just because I'm taking so many questions, I'm going to hold most of them for the end at this point. I might slip in 1 or 2. So if you guys are wondering, I'm not ignoring you. We're just going that way. All right. So what am I looking at here, buddy?
Yeah, this is something we call hanging traces or sometimes dead ends. And this is basically a trace that was created, but it doesn't actually go anywhere or have a purpose. And this might be an extra feature that won't affect the board. But on the other hand, a customer might have accidentally deleted the hole or deleted the trace that completes the connection. So we can't assume that we know what you're trying to achieve here. So we're definitely going to put this on hold.
All right. Thanks, man.
Yeah.
So next up, we've got this, a copper to board edge issue. And Elijah, man, I got to say, this is the sexiest circuit board I have ever seen in my life. Wherever did you find this?
I think you made it, Mark.
Yeah, I did, Elijah. Thanks for noticing. Thanks, man. So what are we looking at here?
Yeah, so another simple fix would be the copper to board edge issue. And on the left side, we can see the copper running all the way to the board outline. And so when we're going to cut this board out, we're going to have copper that's exposed all along the edge. And this could be intentional. It might not affect the board, but it can also ruin the board in some cases. So we're not going to risk that. And we're going to place it on hold and ask if it's intentional or if we can clip it back. And like you see on the right side of the screen. And if you can clip it back on your side, that's usually a quick 5-minute fix compared to an hour or an hour and a half, sometimes even a day hold on our side if we catch it, because we have to ask you and wait for your reply.
Crazy. All right. Thanks, man.
Yeah.
All right. Next issue that we brought up is solder mask opening smaller than pad.
Yeah, so this last issue, probably one of our most common issues for sure. And it's also the easiest to fix on your side, which is going to be our annular ring issue. The image on the left shows the yellow holes and very little copper around that hole. That's the red. And the less annular ring we see, the more chance we're going to have of breakout. And anytime that you're able to increase the annular ring by at least 5 mils or greater, that's going to help you and the board shop to avoid another hold.
All right. Thanks, man.
No problem.
No, come on, computer. There we go. Oh, what am I looking at here?
Yeah, so
Elijah,
that's actually the breakout.
you come up with the best graphics. Wherever do you find these?
I think you made that one, Mark.
I did, Elijah. Thanks for noticing.
Yeah,
so what am I
this-
looking at?
That's actually the example of breakout. The reason why we want the most annular ring you can provide is for reasons like that. Sometimes the drill machine is just slightly off. Sometimes the etch factor just kind of scales it down a bit. So the more annular ring we get, the better chance we have of getting a perfectly contact plated hole.
All right. What about over on the left here? What are all these little yellows and reds I'm looking at?
So that's actually an extremely small amount of annular ring. And what's most likely going to happen is something like your arrow pointing up. That hole, if it drifts off even slightly, it's going to poke out and you're going to get breakout.
Okay. All right, man. All right. Chow, Elijah and I have been monopolizing the conversation with my super awesome graphics. Now, do you think we could pull you into the conversation?
Of course.
Okay. I'm sorry if we put you to sleep with the bad jokes. All right. So let's start talking about assembly issues for a few minutes. Repeated ref deaths. Maybe we could start off telling people what a ref death is, and then we'll go from there.
Actually, I would actually like to tell the customers the files that I would like in order to start the DFA check. So in addition to your bill of materials, I would like the XYRS files and the copper, paste, and silkscreen Gerber layers of your design. And those are the minimum files requirement in order for us to start the DFA check. And so one of the first types of issues that we actually see when we import your bill of materials into our proprietary software is repeated reference designator. And it can happen for multiple types of reasons. Customers could copy and paste it into their program, and for whatever reason, it didn't implement correctly, or the leading letter got dropped off somewhere and it caused a repeated reference designator. And so we'll flag that and we'll compile a list of issues and concerns, and that will be one of the first concerns listed on there. And you would just have to say, oh, I really didn't mean to put L4 on there twice. Go ahead and DNI that, or L4 is actually L41. And so those are the types of issues that we'll see first. And then you just give us feedback on how you want to proceed. Should we keep that as DNI? Was it meant to be something else?
Okay, that's cool. Next up, we've got BOM XYRS mismatch. What's that?
Yes. So in our program, once we import your bill of materials, we'll also import your XYRS file in, and our software compares the two files against each other and look for discrepancies between the two files. So the example you're looking at there on the top is components missing from XYRS file, which means they were found in your bill of materials, but missing from the XYRS. So in that particular situation, you'll either tell me, yes, I want L4, L5 placed. No, I don't want it placed. And then the next issue you're seeing there is the vice versa. So you have components that were not found in the BOM, but they were found in the XYRS. So at that point, you can say, I want C25 installed with this part number, or yes, C25 and C26 are actually DNI components. And so those are the discrepancies we'll find, and you just tell me how you want to proceed with those reference designators that we found.
Okay, thanks, Chow.
Mm-hmm.
Let's move on to value discrepancies. What's this?
One of the most important checks that we do on your files are we take the part number that you're calling out in a particular line item. We go out to, the database, DigiKey, for example, and pull up that part number and see what DigiKey is calling out. So in this particular case here for R32, they're calling out a 120 ohm part, but for some reason, your description value in your BOM says it's 8.2K ohm. So there's a discrepancy there. So we'll catch that. We'll put it in a table and send it to you. And you can say, yes, my part number is correct. I forgot to update my BOM value. So then we'll update it to 120 ohms. Or you can say, that's actually not the right part number. I really want an 8.2K ohm part. Here's the new part number. We'll go, and then if it's a turnkey order, we'll go ahead and put in the request to buy the 8.2K part. So we do that check before it gets out to the machine and it's caught by the technicians out there. So it gives you the opportunity to make that correction before your job even hits the production floor.
So can you remind me again which files I need to make sure to send to you?
Yeah, so bill of materials, make sure it includes the reference designator, manufacturer's part number, and a description with hopefully values and package sizes, the XYRS, and the copper, paste, and silkscreen Gerber layers. If it's double-sided, 6 files minimum on the Gerber layer side.
Okay, and the XYRS file is the...
Also known as the pick and place, so it contains the XY coordinates as well as rotation and side information for all of the reference designator on your build.
Okay, cool, thank you. All right, moving on. I just heard a beep. Do we still have both my panelists?
I'm here.
Yep.
Okay, cool. I don't know what that was. All right, what about some other layout issues? What else do you see on a daily basis?
We see a lot of layout issues with components that are either too small or too big or not ideal for the actual footprint. And this can be due to a lot of different types of reasons, one of which is, you know, in the US, we all use imperial system, and then everywhere else they use metric. And so that sometimes causes confusion because a 0402 to us may mean a 10005 to someone else. But that's actually something that we're seeing. It's actually 1.0 millimeter by 0.5 millimeter. So that type of confusion may cause parts to be sourced incorrectly for that type of footprint. And so, for example, on the left-hand side there, you see an 0402 component on a 0603 footprint. Even though that part may look like it could fit, because of experience and how long we've been doing this, the 0402 size is just way too small on that type of footprint that when it actually goes through reflow, you're going to have the part misaligning or tombstoning, which actually causes a lot of additional rework at the very end. And so I would suggest the customer correcting this and upgrading that part to an 0603 in order to avoid costly rework on their order. For example, sorry. And
no, I was going to say, I run into that all the time as a designer. You know, I go and I pick out an 0603 part, but the footprint for that isn't labeled 0603 anywhere. It's the, oh gosh, what is it? I think it's the 1608. See, man, I just can't do this, Chow. I need to quit. What about the 0805? What's going on there?
Yeah, so what you're seeing there on the 0805 is it's on a 0603 footprint. So although it is placeable, you may see some insufficient soldering issues for that particular part. And not only do we pull or do we actually give you issues that may cause the project to stop out on the floor, we also give customers suggestion on, you know, making these types of changes so that it doesn't hinder their production runs if they ever do decide to take this prototype and then go and book 1,000 order. So this may not be an issue for like the smaller ones, but in the future, if they do ramp up into those thousands, it may cause some sort of issues at the end. So we're trying to make it where the customer have optimization and something that they can actually work with in the larger type runs as well.
Okay. What about this next one? We've got some pictures of thermal pads, and those are some ugly circuit boards. Those aren't mine, right, Chow?
They are not yours, no.
That's right. I'm glad you noticed, Chow. I mean, my board's sexy looking. So what about thermal pads, right? What's going on with this problem?
So what you're seeing there is the physical part has a thermal pad, but the footprint does not. And if we actually look at the different layers on the PCB, the Gerbers, those may be exposed vias. So if you place that particular part on, you can cause some sort of issues. So we'll have to check the solder mask to see if those are covered or not. But in this instance, let's say if the customer did intentionally want to use that thermal pad to dissipate heat, they're not going to be able to do that if they left that footprint as is. So this is the type of discrepancy that we'll catch for the customer and say, hey, your physical part has a thermal pad, but the footprint does not. Do you want to go ahead and change your footprint at this particular time to accommodate or utilize that thermal pad? So this is the type of issue that we see and we'll catch for the customer as well.
All right, so it almost looks like they picked a footprint for like an 8-pin T-SOP, but their part clearly isn't. I did a pretty lousy job of coloring that in. I apologize for that. So do you think they just picked the wrong land pattern or for the footprint, or what do you think happened here?
Yeah, they could, because that footprint does look more like a gull wing type of part instead of a leadless component like you have on the right there. And so that's why we're capturing it and then sending it to the customer to see what they intended to put on that particular footprint. And if they really needed that leadless component, they will have to redesign their footprint here. And in data sheets, you have so many different types of package types for the same IC. And so that may be an issue as well, where they just changed the suffix of the part and it completely called out a different component.
I have done that before, Chow.
Mm-hmm.
Customer wasn't happy. Not happy.
Yes.
Anyway. All right, so what do we got? Oh, here, man, I don't even know what they did here.
Yeah, so that's another example where the customer may have called out a different suffix and selected a package that was a little bit too small for that particular footprint. So if you look at the model in the middle there, where it has the red leads, that's actually a package model in our design files. And we take that base off at the data sheet and we put on the customer's footprint. And obviously the leads don't actually make contact with the pads, which are the blued apertures that you see there. So at this point here, we can't place that part and we'll put it on hold for the customer to review. Again, it depends on what they're intending to do here. Do they want to keep that footprint and change it to a different component? Or do they want to keep that part and then change the footprint? So it depends on what they actually need. So different customers, different resolutions on that particular issue there.
Okay. Oh, now here's a mistake I've never made. You want to know why?
Why?
Because I'm lying. So what common polarity issues do you see?
We see a lot of customers that their footprints are missing silkscreen polarity indicators. Sometimes it's on the actual copper itself, but in this particular issue, you have a speaker that has a positive end, a positive lead, and on the footprint, you don't have any silkscreen indicator to tell how to orient this component on there. So if I left it as is without questioning the customer, my technician would not be able to install this part. They could, but it won't be accurate. And so at this point here, we'll capture that and send it to the customer and say, hey, can you identify the positive lead on the footprint? And then based off of what the customer says, we'll make an identifier on the lead identified by the customer and send that out to our production floor so they can orient this part correctly when they go and install it.
All right. Pin 1 missing.
Another very common issue that we see as well, we don't have any kind of silkscreen indicator. Sometimes the customer will make, the pin 1 pad have rounded corners or the opposite where it has square corners. Something to identify it different than the other leads, but I don't see that here. And so we would not know how to orient the part on this particular footprint. We will capture this exact image and send it to the customer and ask where pin 1 is on the footprint. And then once we confirm where pin 1 is, we'll add a triangle to identify pin 1 for our production floor so that they can orient the component correctly.
Okay, cool. Well, maybe we can give our friends some common do's and don'ts, and then feel free to keep filling up the Q&A. I'm looking at them. I'm just not answering them yet. So maybe we'll do a couple do's and don'ts and then Q&A. Sound good, guys?
Yeah, sounds great.
Cool. All right. So what are some do's?
Some of the do's that I'd like to recommend is take advantage of the free DFM.
Ciao.
Free, so if you are working on a new design, feel free to contact your fab house and assembly house and take advantage of those offers and services. Secondly, go ahead and read your data sheet. Make sure that everything you're designing, all the footprint matches, there's no discrepancies. And then also use your fabricator's note. Like Elijah said, it's very unique to that fab house. And if you are using them, use their design rules so that there's no hiccups in the actual fabrication process. Another thing is to ensure the parts in the libraries have the correct footprint. And so when we give you feedback on an issue, a layout issue that we found during your DFA check, take that and implement those changes in your library so that next time you're designing, you won't incur that particular issue again. And then for unusual design elements and assembly notes that you may have, include that in a README file, preferably in a PDF format for both your fab and assembly houses. On the assembly side, when I say unusual assembly notes, I mean things like if you have, cut traces, or if you had adhesive that you want to add, or if you have hardware components, things of that nature, or if you have things are just unusual for your design, include it in a README, and then we'll read it. If we have questions, we'll come back to you with concerns. And that also segued me to my next note here, to separate your assembly and fabrication notes, because you don't want the fab house to miss fabrication notes because you put it in the assembly documents and vice versa. So make sure you have separate assembly notes for the assembly side and fab notes for the fab side. Just establish an open communication with your assembly house and your fab house. Work with your sales team on both ends. If you have questions or concerns, communicate them freely at the beginning so that we can get it all worked out with you, and so to prevent issues during the fabrication and assembly side. Okay?
Oh, sounds good. So it really is free, like at the quote stage, we can get the free DFM and DFA?
It is very, yes, it is true. It's free. I've helped customers out where we did the DFA checks on their job 5 times or even more. I don't suggest that, but I would just say yes, it's all free. If you have questions or concerns, send us your files and we'll look at them, put it through the DFA checks, and give you everything that we find so that you can make all these revisions before you spend a penny.
That's cool. That's great. Okay. What if I want to get sneaky? What if I want to take the DFM and DFA data that you give me and run away to China?
I can't stop you. We just do it for our customer, just in hopes that, they see how we're willing to help them. And in the future, just give us an opportunity to, do their assembly or do their fabrication. And so we can't stop you. Wherever you take this information, that's up to you. But we just hope that our customer sticks with us and give us an opportunity.
Okay, cool. Hobbyists too, or are you just talking about the big boys? Will you do the DFM for anybody?
We work, yeah, anybody. Joe in his garage right now, yeah, anybody.
Cool, okay. Elijah, maybe some don'ts.
Yeah, some quick don'ts. Don't copy and paste parts without updating your ref des, as this can create duplicate parts. You definitely don't want to do that. Don't change your part numbers without confirming the new value and footprint. And then the last one, don't forget to run your electrical rules check and design rule check. If you check it on your side right before you send it to us, you're going to be able to solve more problems, and we'll have less coming in. So the last thing is, don't ever assume that we understand your design simply because we have your Gerbers. Guessing is a bad thing in my 6 years of being here. It's never gone well. So yeah.
Yeah, if the issue is that if we guess wrong, we're going to have to remake the board at our cost, wasting your time and wasting the boss's money. Neither are good things in the long term for a healthy relationship on either end. So we can't guess. we can't do it. You've got to get it right. Now, as a designer myself, I know how hard that can be. There's so many moving parts, especially for your first board design. So we do have resources for you. Actually, we've got a course. You've got another 2 or 3 days to enter into at teachmepcb.com. We can actually help you out through this. So let's hit some questions and get this thing wrapped up. So first one we're going to knock out is Steve Drake's. Does the pin 1 indicator have to be in copper, or does the silk screen do the job? Steve, either or. As long as they're not conflicting, you can do either one. So you can do a fancy pin 1, maybe make that one round while the rest of them are rectangular round land patterns. That'd be fine. The only thing you don't want to do is have your pin 1 in copper in one corner and then your pin 1 in silk screen in another. Sound good? Chow, anything you want to add to that?
No, I agree with that. So it doesn't matter if you identify it on the silk screen or the copper pads, as long as we're able to distinguish that particular pad from the other ones, we'll be able to orient your part correctly.
All right. Anonymous Attendee writes, how about diodes? What is the common rule for indicating A and K?
Yeah, so diodes is actually a very big one. Not for some reason, some other manufacturers decide to mark the anode side, so that causes a lot of confusion. But for us here, whatever you indicate on the silk screen, like a dot or a line, we will use this industry standard of placing the cathode towards that end. So what you said is we would prefer to actually have the anode cathode symbol on it where it clearly identifies which end is which, and that way there's no question about which side is the cathode, and depending on the part we'll place it correctly. So you can use the universal anode cathode sign. That is the preferred marking on diodes.
Another thing, anonymous attendee, if you can, and it's a small board, not a big production run or anything, just use a 3-terminal LED if that's what you're asking about, because I've ordered from Advanced Assembly, I've ordered from Macrofab, I've ordered from other places too. It seems like 50% of the time, I'm going to get the diodes inserted the wrong way all the time. So as a designer prototype, just use a 3-pin diode and move on with life. It's much less frustration. Of course, you know, they're a little more expensive, so you can't do that on big jobs, but it's so worth it for me. Okay. Chow, it looks like this one's for you. For large thermal or other pads, do you want the paste mask reduced in size? What about windowing as a single thermal pad into multiple smaller paste openings? Do you want to do that one, or do you want me to?
I can do that one. So luckily, we actually don't use stencils, so that question is more geared towards assembly houses that still use the stencils. We actually have 2 My600 paste printers, and so we don't need you to do any kind of modifications on your paste Gerber files. You can just leave it one-to-one with a copper, and then what we do is we take your paste files and generate a CAD file and then a My600 files on our paste printer, and based on how much paste is being released, we actually can go into the machine and reduce or add more or anything of that nature to make the optimal paste release without you having to do anything. We modify that on our side here on our paste machines. So we don't need you to do anything. We'll do that by ourselves.
Okay, thanks. So once again, just to summarize, you don't have to worry about it. We print the paste. So just give us a 1-to-1 opening. We'll do the modifications. You only need to worry about the windowing and whatnot if you're doing mass manufacture where stencils are king, you know, but if you're doing 10,000 of them, yeah, you're probably not going to want to do the paste printer. Okay, so let's jump around a little. Elijah, what are the minimum solder mask slivers?
Minimum solder mask slivers, you're gonna want to go at least 2 mils annular ring around your copper pads, and make sure you have at least 4 mils of solder mask gap between your openings.
All right. Question from Jesse. I think this is for Elijah. It just says outline as part of its own layer or part of drill drawing okay for the automatic check?
Outline can be its own layer.
Okay, cool.
That helps
Thank
all
you.
the way around the board.
Question regarding solder mask. Do we prefer that we provide the solder mask openings at 1-to-1 to the pad? Or do we want to expand those? Or better that we provide the swell we want and you check that it's okay?
Like I said, if you can always go at least 2 mils over the 1-to-1, then that's going to be a safe bet. And then either way, no matter which way you go, we're going to check it. Our software automatically increases it where we can and lets us know where it should have and could not be increased. And so we'll always check that no matter what.
Okay. Question from Jesse, what kind of minimum place bounds for chip components do you have? I believe he's referring to the courtyard. So this would be Chow. Chow, do we still have you?
I'm right here. I'm sorry. So for components,
okay, that's
like...
okay.
Hello?
Yeah, no, keep talking.
Oh, I'm sorry.
No.
So yes, minimum, I would say 10 mils.
Okay. So do you happen to know the IPC standards for the minimum, oh gosh, what is it? Nominal and, no, least nominal and maximum, perhaps. Chip boundaries off the top of your head? I don't remember.
I do not.
I don't either. But I assume we place nominal and least, yeah?
Yeah.
Okay. We can probably do more. The trouble that you run into, Jesse, is that if you exceed that and you really start cramming things in and something goes wrong, there's no room to rework. We can't fix it. That's what we run into. All right, DFM, DFA checks. Jelani asks, do you flag if odd sizes like 0508 are called out?
If they're called out and the footprint's correct, then we do not. But if they're calling out a 0508 on a 0805 footprint, if the leads are more than 50% off pad, then yes, we'll call it out.
Okay, so there we go. Thank you so much. Okay, question from Ben Holmes. Can we just design in metric instead of imperial? Yes, you can. But if you go searching for parts on DigiKey and you type in 0603, it's going to give you an 0603 imperial. It's not going to give you the 0603 metric. It'll give you the metric in parentheses. And that's kind of a pain. It's, you can try, you can certainly try. And gosh, life would be simpler if we all just used metric. But if you live in America, it's kind of hard to do. Sheridan says, for footprint part size mismatch, is there some flexibility if ideal part is not available? Yes, there is some flexibility, but you start running into material property limitation. Go ahead, Chow.
Can I answer that for Sheridan?
Sure.
So yes, per IPC, if we're just catching things per IPC standards. So if you want a part placed and you know it's outside of IPC standard, what you want actually overrides IPC. So if you tell me that you want to place this part on and you just want some sort of solder connectivity, I will go ahead and make that note for the production floor that you understand and you've already approved it. We'll go ahead and put that note for the floor and they'll place the part. So what the customer says overrides IPC.
Okay, cool. Jelani says, if we've got an improved footprint that we suggest to customer, can we change it on our side after getting the Gerbers? Yes, we can rework your Gerbers, but on our end, it's going to take longer and that's going to end up costing you more money. If you can do it on your end, it's going to save CAD/CAM engineers that work 3 shifts. We can get stuff done, but we have to charge you for the time. So there's that. Fiducials, are they necessary for the customer to add, or do we do them?
We actually don't require customers to identify fiducials. We actually use the customer's features. For example, some drill holes on the board diagonally across from each other. We use those as your fiducial, so we do not require customers to identify those.
All right, and on the fabrication side, Omar, we will add those if we need them, especially if we're doing some stuff that tends to shift or we're doing a rigid flex board. If we need a fiducial, we'll just toss it in there. Okay, so Fred asks, and I don't know who this goes to, any way to help avoid gain relief of very fine pitch SMDs? What's the minimum web between pads?
Minimum web is going to be 4 mils. I'm not too sure on the software side how you can avoid that, but anytime we see gain relief, we always separate it. That's our standard. As long as we can get that 4 mil gap, we're going to separate it when we can.
All right, thanks, Elijah. All right, Nicholas, been waiting patiently. As a hobbyist that has never had a board assembled by a company, what can we do to automate getting all the data to you? What and minimize errors to increase a successful first assembled board? Okay, I'll take that one.
Okay.
Unless you wanted it, Chow, I can take it. So we're actually working on that for you. We've got a course over at teachmepcb.com where we're running 600 people through their very first board design, start to finish. And that content, once available, we're converting into white papers and we're posting on our blog at aapcb.com/blog. Also, if you want to call us, we'll walk you through the process. It's not a big deal. Or email me, mhughes@aapcb.com. That's MHUGHES @aapcb.com, and I'll walk you through it. We want you to be successful. We don't mind doing it. We do it every day. Half of our customers each year are new customers who've never done it before, so you certainly aren't alone, Nicholas. So, all right. Ooh, I think I know the answer to this one, but I'm going to leave it to you guys. You're going to love this one. From Osman. Is it sufficient to put fab notes on a Gerber layer, or do I need to include a separate text file? Oh, Osman, you've woken the beast. Chow and Elijah, do we want these fab notes on a Gerber file or in a text file?
Text file is always extremely helpful. I mean, probably 50% of the time they do send it in a Gerber, but it's just 10 times easier, saves us all time if we can get that in text.
Okay. Oliver asks, in a full turnkey build, how do you like to handle multiple part numbers for the same component, like R1 equals 10K, part number ABC for manufacturer XXX, or part number KLM for manufacturer YYY? Some PCB CADs allow for specifying alternate components. Do you have a recommendation for adding alternate components to a BOM? So we've got a lot of questions in here. So, how do we handle multiple part numbers from the same component? So let's say we're doing a panel, and in the lower left, I've got R1 equals 10K, and then, I've got 20 copies of that panel. How do I handle my ref des? Okay, I'll take that one. Let us panelize for you, Oliver. Let us do that, and then we will make sure that it's done right and you've got no duplicate ref des. You cannot have duplicate ref des in the on your end. So if you're doing a panel and you send us the whole panel and you've got 20 copies of R1, we're going to put it on hold and we're going to have to kick it back to you. But if you just give us the one board and you let us do the panelization, we can make sure that they'll all still be labeled R1, but they will all have hidden secret reference designators for the whole panel. They'll be unique. Next question. I don't really know how to answer the next one. Maybe we can follow up in text. But how do we deal with alternate components if we need to run, let's say we run out of 10Ks, or maybe we have some design where half the panel needs to be 10Ks and the other half needs to be 8Ks. How would we deal with that, Chow?
So what we do is if we run out, the actual purchasing team will actually look at the customer's bill of materials for those alternate line items. So if they see something on there and they run out of the original one, they'll use the alternate part number listed to buy more, or they'll go back to the customer to ask for an alternate part number if they don't see those line items in the customer's BOM.
All right, and Oliver, I didn't really understand your second question in there, but maybe if you want to follow up with email, mhughes@aapcb.com, I can try to work with that one for you. Can we request to have finished board assembly shipped to us as an assembled stack-up, say if so 3 boards plug-in together, if given proper assembly documentation and shipping details as an electronic system?
The answer is yes. we can do that. And we have done that for customers where we've assembled multiple boards that actually get assembled together. So yeah, so if you have the proper documentations, we'll be able to do that and ship it to you as a complete design.
Okay, we've got Selva Kumar saying, please send the via webinar invitation. It's a good time to learn on stuff, especially working from home. I said this before the webinar said, but I'll say it again for everybody. We've got webinars coming every Thursday. Additionally, if you guys want individual training for your company or your team, we can schedule a one-on-one webinar on any concept that you want, just with your team. Just get in contact with sales@aapcb.com or sales@royalcircuits.com. Say, hey, I want to learn more about X, and I will set that up for you, and I will pull in the right personnel to make that happen. Sound good? All right. Man, we got a ton of questions. We're into it for an hour. Do you guys have more time, or do you have to go?
I'm available.
Chow, can I hold on to you for a little longer, or do you want me to wing it without you?
No, I'm here.
Okay. All right. How can you know that a footprint is wrong with Gerbers only? From Roger. Roger, we don't. If all we have is the Gerbers and we're fabricating, we can fabricate anything. It's when you get to assembly where we get your parts list, your BOM as well. So if you're not careful and you just do a DFM with somebody else, they will not catch that, right? You can get your board made in China and send it to us. China's not going to know. Offshore's not going to know. You don't see the error until you do the DFA check. It's a separate thing. All right, Elijah, what's the preferred method to specify masking for conformal coat if required?
Say that again, sorry.
How do we deal with conformal coatings? How do we specify masking for conformal coat?
Do you know that answer? I'm not too sure.
I don't know that answer, actually, but we can find out for you, David. Just hit me up at mhughes@aapcb.com. That's mhughes@aapcb.com, and I'll find out for you. I don't know off the top of my head, but
Yeah,
we'll ask John Lass.
Assembly, yeah.
Yeah, he's been doing this stuff for 30 years. We'll find out for you, unless you happen to know Chow. Okay, then we'll have to do that and follow up. The most errors you guys get in customer files, are they CAD software errors, layout errors from other software settings? I mean, your best guess. Where do these errors originate?
I would say, yeah, it's what you're plugging in, the I guess the design rules you're plugging in. Usually they don't match up to what the board shop you're going to use is asking for.
TMSI Tech, in my experience as a designer too, most of the errors I make are when I start changing things. You're not paying attention and you execute some engineering change order. It's supposed to affect one component, it affects 10. You apply to all. Or you have to change parts because one's too expensive or purchasing does it for you. And all of a sudden you've got the wrong package size and you're out of luck. It's just kind of a pain. Oh, Thomas asks, and I'm going to leave this to Chow. We might have to do a follow-up on this. It says, on X-up layouts, what is a good spacing between assemblies?
Are they talking about in panel form?
I don't know. Let's say that they are. What's my panel spacing?
I think that would be more for the fab side, because as long as we're able to place the components on there and there's not any overhanging type of connectors, I don't really have any kind of specification on what the customer should space these boards out. So maybe on the fab side?
Yeah.
Elijah, do you have any requirements?
Yeah, on the fab side, they can actually be touching. That's no problem. The one thing you're going to want to pay attention to is your copper to board edge, because if it's touching, it's going to have to be scored to separate them. And that's okay to have boards sitting against each other. But as we score that, you're going to start running into copper issues as we're cutting into that board. So just make sure your copper's backed off 12 mils. That's the standard. If you're going to V-score and put those boards right next to each other.
Okay. requirement for fiducial marks. Bruce, we don't require them. If we need them, we will add them for you. You do not need to add them for either our assembly or our fabrication. So Raylan asks, this is for Elijah, is it mandatory that the fab drawing shows all the dimensions for board outline, or can the Gerber outline prevail?
It's not required, but it does stop us from putting your board on hold. If we see something that's not going to match up, maybe your Gerber file was somehow scaled on your side before you sent it. We wouldn't catch it if you didn't throw in some dimensions on your fab print.
All right, Theo asks, mils is a millionth of an inch? No, sir, it is 1,000th of an inch. It is the imperial way to pretend that we are using the metric system. So 1 mil is 0.001 inches. What is that? Remind me, Elijah, is that like 0.254 millimeters or 2 point, God, how does that convert? Okay, so 0.254 millimeters. Javier asks, when is it necessary to use impedance control on the printed circuit board? Javier, you do that when you've got high-speed signal or RF traces. USB 3, you start getting into the 10 gigabits per second type stuff. It really what it depends on is the rise time of your signals. If you want to email me, mhughes, M-H-U-G-H-E-S @aapcb.com, I can walk you through that. Really, only if you have high-speed switching signals do you really need to worry about that. Roy says, are teardrop via rings necessary? No, a lot of fab things don't use them, but God, they make it nice. The drills tend to wander when going through copper, and the thicker copper, the more wander you can get. That teardrop can save your via. It can increase your yield. Where are we? The U.S. is officially a metric country. Get with the plan, Stan. Greg, hallelujah. I wish we were metric in real life. Life would be so much simpler. This is for Elijah. I'm not going to mispronounce this name. I can't do it. But the question is there any minimum solder mask requirements for a net tie? As a net tie sometimes looks like an SMD pad.
No, again, just the 2 mil and I guess 2 mil on your ring and 4 mil web spacing is just all we require. Same rules as everything else, whether it's SMD or any type of solder mask clearance.
All right. Drew asks, is there a way to get edge plating? Because we keep saying, pull your copper back, but we do edge plating too. You want to talk about that for a second?
Yeah, we absolutely do edge plating all the time. I have a job right now that I'm working on that has edge plating. It's pretty common on our side. It's not a problem at all. We do all the work on our side. You just specify where exactly you want it, and you make sure you put your copper to the board edge on where it's located. But the fab print should have a note saying, here's exactly where I want it. We're going to prepare the files to do so.
Okay, how do we identify castellated sides?
Castellated sides, you can, what most people do on the fab print is they actually have a mini drawing showing the top and bottom of the board and showing what side, it's a literal drawing of what side they're castellating, or you could even put it in one of the fab notes written as I require castellated hole from the top side.
All right, Javier asks, is it essential for the PCB designer to have a thorough knowledge of the IPC standards? Would you like to recommend resources for learning about IPC standards? And I do realize, by the way, that we are having some audio issues. We're trying to troubleshoot that. We're having some difficulty while the webinar's engaged. Yes and no, Javier. The IPC standards are all locked behind a paywall. You cannot view them yourself. You can only see references to them unless you want to pay the $180 to go see it. So usually most designers just pick that up along the way. A lot of technical articles will reference IPC standards. So you let the technical writers like me read the standards, interpret them, and then report back to you. And there's IPC standards for everything. IPC 2221, that deals with, or at least it used to deal with, some heat and thermal high voltage requirements. That got supplanted by IPC 2152, which deals again with heavy copper. And I mean, it's just it gets crazy. There's no way for you to sit down and read a book because each of these documents is, 80, 100 pages. The best way is to start reading things like SI Journal, Signal Integrity Journal, iConnect 007, and pull the information out of those. Some books, like if you're dealing with high current, heavy copper stuff, Douglas Brooks and Johannes Adams has a book, and you're like, well, then I have to buy a book. Well, yeah, but if you go to Dr. Brooks' website, ultracad.com, you're going to see that he posts all the information in articles for free, so that you don't have to buy anything. So there's a lot of resources out there. If you want to email me, mhughes@aapcb.com, I will try to find some for you. Somebody helped us out with the conversion. It's 0.0254 millimeters per mil. Thank you for that. Okay, we're going to finish what we have here and then we're going to bail. Thank you for those of you who are still hanging in there. I know we're starting to wear down. It's been over an hour. For PCBA, is it better for a customer to send the parts, or is it preferable for the PCBA company to acquire them? Let us acquire them for you, Omar. We do consignment, and we can take whatever you have. But I mean, your parts are going to be probably sitting around for a while. Everything we get from DigiKey, we get the day of assembly or the day before assembly. We're their 6th to 7th largest customer. Let us acquire your parts for you. It makes the job easier. Everything we do is going to be ESD controlled. You ship this stuff around. You don't know what's happening to it. Moisture content. Now does it have to be rebaked? It's a pain. Let us get them for you. Does the side of the substrate get treated somehow so that the side of the substrate gets plated? Yes. Elijah?
One more time, sorry.
For side plating, how do we plate gold fingers and whatnot?
Oh yeah, so basically it's kind of weird to explain. We extend those fingers out a little bit longer than normal and have a copper trace that connects all your fingers together, and that trace goes all the way to the copper ring that goes around the entire panel as we're building your board. And so when we're plating, that's making sure everything's getting plated properly. And then right before we test the board, we take a router and cut that trace we added to disconnect everything and make sure that your connections are still proper.
Okay, Jelani, if a customer gives you their board is a high voltage board, do you give creepage and clearance recommendations or restrictions per ICP standard? No, sir, that is on you. We get copper files. The Gerbers don't tell us that you're running 50 volts through these. They don't tell us that you're running 1,000 volts through these. We don't know. That's on you. However, if you want to shoot me an email, I think I've asked you so many times, I'm sorry. But if you want to shoot me an email, I can give you some indications of what the creepage and clearance are for voltage. I can give you the back door into the IPC 2221 and 2581 standards. So just shoot me an email. I'll help you out with that. Can either company do a Minter Valor DFM DFA check, or what software is used for DFA? Our DFM DFA is proprietary software. However, we work with pretty much all of the CAD formats. If you send it to us, we will get it done. So there we go, anonymous attendee. Do you have a recommended board stack up based on technology and min and max tray sizes? Yes, we do. If you go to royalcircuits.com and look at the resources, you will see that we do have recommended board stack ups for you ready to go, 2, 4, 6, 8, however many layers. And if you want more than that, you just talk to our design engineers, Omar and Teresa. You can do that through your salesperson, and they will work with you with whatever you want. Down to one question. Ciao. This is all you. You ready for it?
Yeah, so for us, we actually use no clean flux, no clean solder paste. So that's our standard in-house. And so with those different designs, if you're not calling out something specific, then that's what we're going to use with no wash at all. With customers who don't like the residues that are left over, even though they're non-conductive, it's not aesthetically pleasing. So for those instances, we do have a chemical wash that we can put your boards through, which will remove all of those flux residue. So that's our standard in-house. We can still do water-soluble type of paste and flux if requested by the customer, but they would have to request that in their document.
Okay,
and then we would have to buy a sample. Yep.
David says, can you talk about tin whiskers? Tin whiskers aren't much of a problem anymore now that we, I mean, back when we went from leaded solder to lead-free, ROHS, they were still perfecting the mixtures, the metallic mixtures. And yes, tin definitely whiskered, caused short circuits. It was a pain in the butt. Not so much a problem anymore, but it's going to depend more so on the solder composition that you use to attach your parts to your board than the assembly process. So with that, I would like to thank everybody for joining us today. I want to remind you that every Thursday in our Talk Teach Tech Thursday sessions, we're here to give information for you. If there's something that isn't on our schedule that you want for yourself, your team, your company, just contact your salesperson and we will arrange it for you. It's a free service. It's an add-on. We do this, 20 minutes, 30 minutes. It's not a problem. We can do, what are we like at 75 minutes now. Whatever's useful to your company, whatever topic you want, we're here to work with you. Next Thursday, we're talking about VIAs. You still have, if you want to learn more about boards, how to build them, you still have 1 or 2 days to sign up at teachmepcb.com. That is actually hosted by Royal Advanced and several other companies. We can teach you about this stuff. Or if you want to keep checking out our blogs, we're going to continually put white papers in there for you. You guys can learn everything that you want to know through reading. I know reading's exciting these days in the work from home statements. If you do have any specific questions for Chow and or Elijah, you can reach them at chow@aapcb.com or Elijah at royalcircuits.com. And we've also included their phone numbers for you. I am mhughes@aapcb.com. Elijah, Chow, any final thoughts?
No, just appreciate all of you for attending.
Definitely.
Yeah. It's been a great webinar. We had hundreds of people. This is one of our biggest ones yet. So I want to thank everybody for coming in. We will download this webinar and we will present it to you in probably a day or two at our blogs at royalcircuits.com/blog and aapcb.com/blog. All right, guys, that was intense. That was crazy, but thank you so much for joining me today.
Thank you.
And
Bye.
with that, we'll end it. Have a great day.